Welcome back to the chapter Real Numbers, part 9. So, we have already discussed what is Euclid's division lemma. So, we are going to do some problems, applications of the Euclid's division lemma. So, what is Euclid's division lemma? It is any integer can be written in the form of a equal to bq plus r, where 0 less than equal to r less than b. So, we have to prove here that every positive even integer is of the form 2q and every positive odd integer is of the form 2q plus 1, where q is some integer. So, let us assume let a be any positive integer. So, here you have to prove that it is of the form 2q, even is 2q and odd is 2q plus 1. So, here we will assume b is equal to 2. So, b is actually the divisor. So, by Euclid's division lemma we can write a is equal to bq plus r. So, here a is equal to, in the place of b, 2. So, 2q plus r, where r will be equal to, we have discussed earlier, it will be always less than the divisor. So, it can be either 0 or 1. It cannot be equal to 2. It can be only 0 or 1. Yeah. So, now a is equal to, when r is equal to 0, a is equal to, now substitute in this, you will get a is equal to 2q. So, we know any number multiplied by 2 is a even integer. So, this is a even integer. So, when r is equal, now when r is equal to 1, a is equal to 2q plus 1. So, 2q is an even integer. So, 2q plus 1 is a odd integer. So, we have proved that even integer is of the form 2q and odd integer is of the form 2q plus 1. So, even integer is of the form 2q and odd integer is of the form 2q plus 1. Now, show that any positive integer is of the form 3q, 3q plus 1, 3q plus 2 for some integer q. It is of the same method we have to use. Let a be any positive integer and b is equal to, here since you have to show it is of the form 3q, 3q plus 1, 3q plus 2, we will take b is equal to 3. So, a is equal to bq plus r, that means a is equal to 3q plus r, where r is equal to, now since b is 3, r is equal to 0, 1 and 2. Now, when r is equal to 0, a is equal to, you will get a is equal to 3q. When r is equal to 1, a is equal to, now 3q plus 1. When r is equal to 2, a is equal to 3q plus 2. So, that is it. So, we have proved that any positive integer can be of the format 3q, 3q plus 1 or 3q plus 2. Show that any positive odd integer is of the form 4q plus 1 or 4q plus 3, where q is any integer. So, let a be any odd positive integer. So, when a is equal to, so we will take b is equal to 4, because we have to write it as 4q plus 1 format. So, by Euclid's division lemma you can write a is equal to 4q plus r, where r equal to 0, 1, 2 and 3. So, when r is equal to 0, then a is equal to 4q. So, this you can write it as 2 into 2q. So, this is even. Now, when r is equal to 1, A is equal to 4q plus 1. So this is equal to, now 4q is even, so even plus 1 you will get, it is an odd number. Any even, along with one even number, if you add 1, the next number is an odd number. When r is equal to 2, then you will get 4q, a is equal to 4q plus 2, that is equal to 2 into 2q plus 1. So again, so this will become, this is an even number again, and r is equal to 3, a is equal to 4q plus 3. So that is again 4q plus 2 is even, so 4q plus 2 plus 1, so this is odd. So here now 4q plus 1 and 4q plus 3 are odd. So any positive integer, therefore any positive integer is of the form, positive odd integer will be of the form, positive will be of the form 4q plus 1 and 4q plus 3. If they ask you to say any integer is of the form 4q plus 1, 4q plus 2, 4q plus 3, then you have to simply write just this. But here you have to prove it is of the form, odd integer is of the form. If suppose they had asked you even integer, then even integer is of the form 4q or 4q plus 2. Now show that the square of any of an odd positive integer is of the form 4q plus 1 for some integer q. So let x be any odd integer. So if you, for writing an odd integer, you can always write 2m plus 1 for some integer m. So x squared, so you have to find the square of the odd integer. So odd integer, this square of this will become 2m plus 1, the whole squared is equal to, this will become 4m squared plus 2 into 2 4m plus 1. So this is equal to 4 into m squared plus m plus 1. So this is equal to 4q plus 1, where q is equal to m squared plus m. So you got the square of the odd integer x is equal to of the format 4q plus 1. See you all in my next video with more problems. Bye for now.